Hello again. So good to have you here. Last time I took you on a whirlwind tour of Twistor Theory, a rather abstract concept by Roger Penrose that suggests light might be more fundamental than the usual four-dimensional stage of space and time. Some parts might have seemed daunting, so I promised we'd slow down and look at what these ideas mean in simpler terms, especially regarding the possibility that our familiar notions of space and time could be secondary to light, and how that might connect to human consciousness. First, let's set the stage. In ordinary science, we describe events by their positions in space, x, y, z, and a moment in time, t. That's 4 coordinates total, t, x, y, z. Meanwhile, light, the stuff that travels at roughly 300,000 kilometers per second, often just seems like a useful signal telling us what's happening in the universe. But what if we turned this around and said, no, light is actually the core ingredient. Let's focus on it, and let space and time emerge out of that framework. That's the core idea behind Twistor Theory. Instead of labeling the universe with points in space and time, it labels everything in terms of light rays and their peculiar mathematical properties called Spinors. Now, why would that be interesting? Here's what we know, and this part is well-established science. Light always moves at the same speed, regardless of how fast you're going. Time and space aren't as absolute as we once thought. Einstein's relativity showed us that they can stretch and warp. In quantum mechanics, particles sometimes behave in surprising ways, and describing them often relies on wave-like functions and complex numbers. Twistor Theory takes these known facts and tries to reorganize them into a new picture where light is central. It has had some practical successes in simplifying certain high-level calculations in quantum field theory. However, most physicists still consider it a niche approach, far from being universally accepted or proven as a unifying theory of everything. But then there's the speculative part. What if, by making light the foundation, we discover that space and time, the very fabric we navigate in daily life, are just outcomes of deeper structures? In other words, maybe our usual sense of there and then isn't the ultimate story. This is not established fact. It's more like a research direction that intrigues some scientists and philosophers. If that turns out to be true, it could open doors to new ways of thinking about the cosmos, and quite possibly about ourselves. Which brings us to consciousness. Our awareness, this immediate sense of being here, doesn't neatly fit into the usual equations of physics. Some researchers suspect that the standard picture of matter arranged in space and time just isn't enough to account for the richness of conscious experience. Could Twistor Theory, or a related light-first approach, offer hints about how consciousness ties into the physical world? Perhaps. But let's be crystal clear. This is firmly in the realm of conjecture, not experimental fact. Why do people even entertain the idea that consciousness and light might be related? One simple motivation is that light doesn't experience time the way we do. From a photon's point of view, speaking loosely, since photons don't have experiences, the journey from one end of the universe to another might be instantaneous. Meanwhile, our conscious experience stretches moments into a flow of time, past, present, future. Some suggest that perhaps consciousness is more aligned with these null rays, or light-like paths, than with what we usually call massive objects in space. Again, that's a leap of imagination, not a demonstrated fact. It's more of a philosophical nudge that says, don't assume you already know what's fundamental. We should also talk about why speculation about consciousness arises in the first place. Twistor Theory uses complex mathematical objects, Spinors, to describe what's going on at a fundamental level. And in quantum mechanics, wave functions, also described by complex numbers, have properties that are deeply intertwined with measurement, observation, or, some might say, mind. While most physicists prefer to keep consciousness separate from the physical equations, a minority wonder if there's a link that might become clearer as we push deeper into the geometry of quantum theories. Twistor Theory could be one stepping stone on that path, or it could be a dead end. For now, it's an open question. Let's remember something crucial. Even if space and time do turn out to be secondary in some advanced theory, it doesn't erase our everyday experience. We still walk around, measure things, and use clocks. But think about how such a discovery could affect our worldview. If everything around us, stones, trees, even our bodies, is fundamentally woven from relationships defined by light, then the human urge to categorize reality into neat boxes of space might be just that. An urge, not an ultimate truth. That alone can shift how we approach questions like, what does it mean to exist? Or, where do I, as a conscious being, fit into this vast cosmos? This leads to a final point. What would proof look like? From a strict scientific viewpoint, we'd need testable predictions. Twistor geometry so far has mainly shown its value in recalculating certain particle interactions more elegantly, but not in giving us a revolutionary new experiment that conclusively confirms its take on spacetime or on consciousness. If, in 10 or 20 years, research reveals phenomena in cosmic rays or gravitational waves that are best explained by Twistor math, then we'll have stronger reasons to believe we're on the right track. Until then, it remains an intriguing alternative approach, coupled with bold speculation about how it might someday illuminate the mind. So, to sum up, established science says light is invariant and central to relativity, and we know quantum mechanics relies on complex, wave-based descriptions. Twistor theory leverages these to streamline certain calculations and offer a fresh viewpoint on space-time. Speculation suggests this light-first view might eventually tell us that space and time are emergent concepts, and might even be key to understanding consciousness. Reality check. We don't yet have concrete experimental proof that Twistor theory is the grand unifier, or that it explains how our minds work. It's more of a conceptual playground where curious scientists and philosophers explore big, potentially transformative ideas. I hope this more approachable take helps clarify why some people get excited about Twistor theory, while others remain skeptical. It's a testament to human creativity in physics. We keep trying new angles, sometimes literally, to comprehend the strange and beautiful universe we inhabit. Whether space and time turn out to be truly secondary to light or not, just asking that question can broaden our horizons, prompting us to reflect on who we are and how we experience reality. Thanks for joining me in this easier-going exploration. If you have more questions, I'd love to hear them. Until next time, keep pondering these cosmic puzzles with an open mind, and a dash of healthy skepticism. After all, sometimes the act of asking, what if, leads to the greatest discoveries.